Good evening, Dr. D. My name is Mike Mendez, and today I'm going to be explaining to you the X-ray circuit. All right, so here's our standard X-ray circuit. We're going to start off here. I'll start on this end and move our way down. We'll talk about each of the parts and how they work. So starting off here, we've got our primary circuit on this side here, and then we have our secondary or high voltage circuit on this side here. Okay, so we're going to have to look back at some of our prior knowledge, and we're going to start talking about volts. So coming into the building, this would be your hospital, and the normal volts coming into any house or any building are going to be 220 volts. So we've got 220 volts coming in to the building here. All right, and then they're going to have a transformer or at the switch here. So this is your on switch. It's going to convert it to 110 volts. So all throughout this circuit right here, we've got 110 volts at 60 amps. So the way this is going to work here is the lines are going to come in. We've got two lines that start off here. Everything comes simultaneously. Come in here, and then we have a third line coming down, but we'll get to that in just a second. So like I said before, we're going to, the two lines are going to come in, head here. Now what we have here is your KV selector, right? So what's going to happen is as the X-ray technologist is at their machine, they're going to choose a KVP. So a KVP that we'll choose today, let's just say, let's go with 200. 200 KVP, that's what's reading out on the screen here. So right here is our KVP selector. So let's just say that it works in 10, so it'll say 10, 20, 30, 40, 50, all the way on up to 200 KVP. And right here, this selector is just going to move. As it moves, it's going to find the 200, it's going to land at the 200 KVP. Right here is going to be our first point of induction. Now, if you remember from our prior knowledge, induction is going to be the arcing of that electricity there. So we've got induction number one here. That KVP is selected, and it's going to come in, and it's going to move around here. Now we have our time circuit. So the time circuit is also going to be where at the machine or at your control panel, where the technologist is going to put in the time. It's going to work like a drawbridge. So the time is going to come in, it's going to complete the circuit, let's just say for 3 seconds, 1, 2, 3, and then the circuit will open up. This causing that electricity to flow through the circuit for those 3 seconds and come through. We're still working with 110 volts. Now for this to be a complete circuit, just remember it's coming back through here as well to your kilovolt meter, which is reading your numbers actually on the panel. Now right here, we have our step-up transformer. So from our prior knowledge, we know that there's less coils on this side. For the 110 volts, that is going to actually jump over here, our induction point number 2, and that's going to give us 10,000 volts. We're going to get back to that in just a second. Let's go ahead and continue on here with line number 3. Line number 3 is going to give you your MA here. So we're coming down. Right here we have an MA selector, just like our kilovolts. It's going to be read on the machine. So let's just say that we have 500 MA. And it's going to find our selector here, and then it's going to have another point of induction there. So we're going to our induction point number 3. Right here to make that circuit. It'll continue coming around. And right here we'll get to this. This is the opposite here. We've got a step down. And we'll come talk to that in just a second. But to complete our circuit, we have induction number 4. Now, if you remember our prior knowledge, you need to have a complete circuit. So this wire here can't just stop. It needs to come around to complete the circuit to keep everything flowing. Now, back down here on the bottom, we go from 110 volts. Got 110 volts, and that's going to come down to 5 to 15 volts. and 3 to 5 amps. So we're jumping over right there. We've got induction number 5. And so these two are very similar, just opposite. Step up, step down transformer. So let's go ahead and continue up here where we started with the MA section that's going to be coming on over to the X-ray tube. So as this arcs, it's going to be making 10,000 volts. The 10,000 volts goes to the MA meter. It's going to read it. If it reads at 10,000 volts, it's going to go ahead and send it out and continue on its way. If it doesn't get 10,000 volts, if it gets over 10,000 volts, it's going to send it right here to the ground wire, and it's going to kill that at that point. It won't continue on because we can't have any less or any more than 10,000 volts. If it's less than 10,000 volts, like we said, it actually won't be able to make this induction happen here, and it'll stay in this primary circuit. So as we're moving on, we'll continue talking about here. So we've got the MA meter, like we just said, also attached to the MA meter. That 10,000 volts is going to go into a capacitor. So here's our capacitor, and then the capacitor is also going to be connected to a falling load generator. So the way the falling load generator is going to work is it is going to just drop 10,000 volts. So 10,000 volts, there's one. Another one, 10,000 volts, just like a water faucet, 10,000 volts, dropping and bringing them into the circuit here. And the way it's going to work into that circuit is coming from the bottom here. It's going to come on up this way. This is our X-ray tube. Come up. Here, there's one part of the circuit. Now, if it's coming from the top, I'm going to grab a different one here for you. It's going to come down this way, following the line just the opposite way here, back to our X-ray tube. And then completing that circuit there. So from that point, we've got this coming in at the anode point of the tube. So now we need to talk about the cathode side of the tube here, where our MA selections come in. So it's going to continue on, like we said, the 5 to 15 volts. And it's also going to make a circuit here. Come back out. Just a circuit like the previous one before. And so now we've got our 10,000 volts coming in on our anode side, and our 5 to 15 volts coming into our cathode side. So that being said, we'll go ahead and switch over now, and we'll talk about how the tube works. Write my notes here. So here we go, we'll start off on this side. This is where our 10,000 volts are coming in on our anode side. We've got our stator electromagnets. So the stator electromagnets is what's going to make our rotor spin. All right, the rotor is going to be surrounded here. We've got bearings here inside the rotor that's actually going to keep this molybdenum stem in place, and it's going to help it to actually rotate without moving around, and also without getting caught up on the rest of the machine here. Then moving forward, like we said here, we've got our molybdenum neck and base right here. This is made of molybdenum for its high boiling point. But moving forward, we have a higher boiling point from the front side here. We've got our tungsten anode, which is going to, like I said, it's chosen for its high boiling point and its high atomic number. So coming back on this side, our 5 to 15 volts coming in from the filament section here. Okay, so this right here is where thermionic emission is going to happen. The filament's going to heat up, and it's going to release that thermionic cloud. When the thermionic cloud releases, this focusing cup is designed to keep it focused, coming right at the anode. It's going to hit the anode, and what comes down here is going to be our X-ray photons. Now, not all the X-ray photons come through here. Some of them are going to come and they're going to cloud out into here. And as the envelope cools, those extra photons will end up collecting around the envelope here, which will cause, or what's called tube arcing. Then beside tube arcing, we have one more failure, which would be the breakage of the filament from just overuse from high heat or from boosting and holding that on. All right, this concludes my presentation. Thank you, Dr. B.